All right, so now we're going to talk about synthesis reactions for a little bit. Synthesis reactions follow a very simple pattern. You have two elements. One of them is a metal. The other is a non-metal. And we're just going to put them together. They're going to react and combine together. When they do that, though, we need to make sure that their charges are balanced. So we're going to take these two elements, sodium and oxygen, and combine them together. We're going to go to the periodic table. We're going to look up their common charges. Sodium is always a +1. Oxygen is always a -2. So its formula would be Na2O. So we're going to go up here and add the subscript for the sodium. After we've done that, we then need to balance the equation. Remember, it's charges first. That's what we just did. Now we're going to balance the reaction. And in order to balance this reaction, the first thing we're going to fix is the oxygen. There are two of them here. So I'm going to come over here and put a 2 in front as a coefficient. That changes the sodium also. The sodium is now 4. And I'm going to put a coefficient of 4 in there. For my states of matter, I am going to use some common knowledge, some of my solubility rules. What is oxygen's state of matter? Gas. And sodium as a standard state is a solid. Now, according to the solubility rules, oxides are solids. They're insoluble. You have access to your solubility rules on the back of your periodic table. Feel free to look them up. Right there it says all oxides are insoluble. All right, here we have an example of a synthesis reaction involving a metal oxide in water. And when metal oxides react with water, they make bases. And what do all bases have in them? Hydroxide. And my sample equation is not balanced, but we are going to balance it. So here's the metal with hydroxide afterwards. We are going to balance it in our sample equation here. What's the metal in this example? Strontium. So we're going to have strontium with hydroxide. And when we put them together, you need to think about the charges. Strontium's a +2, hydroxide's a -1. So we need 1 strontium, 2 hydroxides. Now that we've done the charges, we need to balance the reaction. Is this reaction balanced? Yes, it is. We have 1 oxygen, that's 2 oxygens over here, and 2 oxygens, 2 hydrogens, 1 sulfur, 1 sulfur. No, I couldn't, strontium, sorry, yeah. I couldn't balance the sample equation because I didn't apply a charge. This could be any metal of any sort. This is just the general equation saying that metals with oxygen, when they react with water, will make some sort of metallic base. So it depends on the metal as to what the equation would be. So I give you a sample here with strontium oxide. States of matter. Hydroxides are generally insoluble. They're solid. Water is usually a liquid. And oxides are usually solid. So you would drop this solid into the water, and some of the solid might react and make strontium hydroxide. Here's what's very similar. This one, though, involves a non-metal oxide. So we have a non-metal oxide reacting with water. And when non-metal oxides react with water, they make a ternary acid. A ternary acid is an acid that involves a polyatomic ion of some sort. Again, this is a non-metal here. It could be sulfur, it could be phosphorus, it could be a number of non-metals, it could be nitrogen. It's a non-metal reacting with water. So in our sample, the non-metal is sulfur. We're going to put all this together, and what's going to be the formula of the acid we're producing here? H and SO. How many oxygens are there? 3. And this is sulfite. Sulfite has a -2 charge, so we need 2 hydrogens on there. And the reaction's balanced. It's very common with our reactions. We're just going to kind of put everything together here and check to make sure the charges would work. Hydrogen's a +1. Hydrogen's a +1. Sulfite is a -2. So these charges do work just fine. This example is very similar to the last one. We have a metal oxide and a non-metal oxide. And we're going to put this all together, and we're going to make a metal with a ternary salt. And again, that means that it's a metal and some sort of polyatomic ion. General rule is we're going to put it all together and see if the metal and the polyatomic ion, if the charges balance out nicely. So we have our metal here is sodium. The polyatomic ion would be sulfur with 3 oxygens, which is sulfite. And we would need 2 sodiums. Happens to work out perfectly. Sodium's a +1. Sulfite is a -2. So we would need 2 of these. And so these charges do balance out as we form this ternary salt.